Welcome to Fantastic Stories. Despite the current impressive scientific developments in the search of extraterrestrial life, detecting life on other planets remains a challenging task. As our methods of searching for extraterrestrial life remain limited, our technological capabilities may not yet be sophisticated enough to detect signs of life on distant planets or signals from distant civilizations. Detecting biosignatures of life on alien planets. Biosignatures are substances or phenomena that can provide evidence of past or present life on other planets. While the search for biosignatures beyond Earth is ongoing and evolving, there are several key substances or phenomena that scientists consider as potential indicators of life when detected in an exoplanet's atmosphere, surface, or subsurface. Some of the main biosignatures include oxygen. Molecular oxygen is a highly reactive gas that is abundant in Earth's atmosphere due to photosynthesis by plants, algae, and cyanobacteria. The presence of significant amounts of oxygen in an exoplanet's atmosphere could indicate the presence of life forms producing oxygen through photosynthesis. Methane. Methane is produced by biological processes such as microbial activity in anaerobic environments, as well as by geological processes. The coexistence of methane and oxygen in an exoplanet's atmosphere could be a strong indicator of biological activity, as methane tends to be rapidly destroyed in the presence of oxygen. Nitrous oxide. Nitrous oxide is another gas produced by biological processes, indicating denitrification by bacteria. Detecting nitrous oxide in an exoplanet's atmosphere could suggest the presence of microbial life. Ozone. Ozone is a molecule composed of 3 oxygen atoms, and it forms when molecular oxygen interacts with ultraviolet radiation. The presence of ozone in exoplanet's atmosphere could indicate the presence of oxygen and UV radiation potentially produced by biological activity. Hydrogen sulfate. Hydrogen sulfate is produced by certain types of anaerobic bacteria and is commonly associated with environments such as swamps, marshes, and hydrothermal vents. Detecting hydrogen sulfate in an exoplanet atmosphere could suggest the presence of anaerobic microbial life. Water vapor. Liquid water is essential for life as we know it, and the presence of water vapor in an exoplanet atmosphere could indicate the presence of liquid water on its surface or subsurface. Complex organic molecules. Detection of complex organic molecules, such as amino acids, nucleotides, and other organic compounds, could suggest the presence of prebiotic chemistry or biological activity. Surface features. Certain surface features, such as presence of seasonal changes, polar ice caps, or the presence of liquid bodies like lakes and oceans, could also be indicative of habitability and potential biospheres. While these substances are considered potential biosignatures, their presence alone does not necessarily confirm the existence of life. Detecting biosignatures requires careful analysis and consideration, along with a comprehensible understanding of a planet's environment and geological history. Additionally, abiotic processes must be ruled out before considering the presence of life. Detecting biosignatures of life on other planets, especially potentially habitable ones, is a challenging task due to several factors, including the possibility of false positive or false negative discoveries. The main problems associated with detection of biosignatures may include complexity of life. Earth serves as our only example of a planet with life, and even here, defining what constitutes a biosignature is complex. Life on other planets might manifest in ways very different from what we are familiar with. For instance, alien life might not rely on the same biochemical processes as life on Earth. Abundance of abiotic processes. Many chemical processes can occur on planets without the presence of life, producing molecules that may be mistaken for biosignatures. For example, abiotic processes can produce methane, which is often considered a potential biosignature due to its abundance on Earth, but it can also be produced by geological processes. Interference with non-biological sources. The presence of non-biological sources, such as volcanic activity or photosynthesis reactions in a planet's atmosphere, can produce molecules that mimic biological processes. Distinguishing between those sources and true biosignatures is challenging. Limits of detection. Current telescopes and instruments have limited sensitivity and resolution, making it difficult to detect subtle signatures of life on distant planets. Future missions and technologies will need to improve sensitivity and resolution to overcome these limitations. Sample contamination. In missions that aim to directly sample extraterrestrial environments, the risk of sample contamination from Earth microorganisms is a significant concern. Contamination could lead to false positives, where the detected biosignatures are actually from terrestrial life. Incomplete understanding of habitability. Our understanding of habitability is still evolving, and there may be environments that are habitable for life forms very different from those found on Earth. Detecting biosignatures in such environments would require a broader understanding of potential habitats for life. Limited observational data. Our ability to observe exoplanets and analyze their atmospheres is limited by the available data. As observational techniques improve and more data is gathered, our ability to detect biosignatures will likely improve as well. In summary, addressing these challenges requires interdisciplinary efforts involving astronomers, astrobiologists, geologists, chemists, and engineers to develop robust methods and technologies for detecting biosignatures on potentially habitable planets. Additionally, continued exploration and study of extreme environments on Earth provides insight into the range of conditions in which life can thrive, expanding our understanding of habitability beyond Earth. Thank you for watching. If you enjoyed the story, consider subscribing to my channel. Have a great day and see you next time.